Hello everyone. Today we will be continuing our discussion of probability theory with an overview of probabilities and odds. Now, when we are looking at a sample space, which we've talked about in the last couple of videos, every event in that sample space is going to have a probability. So the thing about these probabilities is that they all have to be somewhere in the range of 0 to 1. So this is true for the probability for every event in the sample space. The probability of the impossible event, which, as you may remember from a couple of videos ago, corresponds to no outcome, that's going to have a probability of 0. The probability of the certain event, which is the whole sample space or every possible outcome, is going to be 1. Every other event is going to be somewhere on that 0 to 1 scale. So we refer to the probabilities that go with all of the different simple events in a sample space as a probability assignment. And the combination of a probability assignment and our sample space is what we refer to as a probability space. Now, let's look at an example of what this actually looks like. So let's look at a simple example of just rolling a 6-sided die. So in this case, rolling a 1, rolling a 2, 3, 4, 5, 6, all of those are going to be equally likely. So the probability in this case is just going to be 1 over n being the number of possible outcomes, or 1/6. The next example we'll look at after this, where we'll be dealing with an example where not every event or every simple event is equally likely, but for this one it is. So we would refer to this as an equal probable space, meaning every simple event in that probability space is equally likely. Now, let's say we wanted to find the probability of 1 or 2. So we have an event here, 1 or 2, that has two component outcomes, 1 and 2. So the way we would go about figuring out the probability of this is we would just add up the probabilities of the component simple events. So the two simple events that are the components here are 1 and 2, both of which have a probability of 1/6. So the probability of this event would be 1/6 plus 1/6, which would be 1/3. Now, if we wanted to find the probability of the whole sample space, we could do the same thing, just add up the probabilities of every single simple event in the sample space. So in this case, we have 1/6 and we have 6 of them. So you could just say 6 times 1/6 or 1. When we're looking at the probability of the whole sample space, that's the sum of the probabilities of all of the different simple events that we have. That should always add up to 1, because this is the certain event, which is always going to have a probability of 1. So when you have a probability assignment for all of the simple events in your probability space, you need to make sure that all of the simple event probabilities add up to 1. So let's look at an example next where the probabilities are not the same for all of the possible outcomes. So this is a 3-player game where we have 3 players, A, B, and C, and we're saying that the probability of A winning is 0.2, 0.5 for B, 0.3 for C. So let's say that we wanted to find the probability of A or B winning. Now, there's actually a couple different ways that we can go about doing this. So the first one is similar to what we just did in our last example. We can just add up the probabilities of A and B. So we would do 0.2 for A plus 0.5 for B, and that would give us a total probability of 0.7. The other thing that we can do is we can use something that we call complements. A complement refers to, or complementary events, I should say, refer to two events that the probability of them adds up to 1. So when we're dealing with something like this, we could say that this A or B represents not C, so the complement the two complementary events here would be C and not C. The way we would go about finding this probability of not C would be 1 minus the probability of C, which is 0.3, and that gives us 0.7, exactly the same thing that we got whenever we did this A or B. So, if you wanted to write this in a general way, so you could say something like PR of not E equals 1 minus the probability of E. And this is for complementary events. The next thing for our example of the 3-player game over here is we want to find the probability of the full sample space. Now, in theory, this should add up to 1 because the full sample space is the certain event. So the way we would do this is we would just add up the probabilities for A, B, and C. So that would be 0.2 plus 0.5 plus 0.3, which does in fact add up to 1. The next scenario that we'll look at is the scenario of independent events. What is an independent event? Well, independent events are two events where the outcome of one does not have any impact on the outcome of the other. So an example of this might be, say, you are flipping a coin 3 times. The outcome of the first coin toss doesn't make any difference to what the outcome of the second coin toss. Neither of those makes any difference to the outcome of the third coin toss. We have 3 different coin tosses. Those are 3 independent events. They all happen completely separate from one another. So when we have a set of independent events, we can use what we call the multiplication rule for independent events. And this basically says that the probability of event E and F is just the product of those 2 probabilities. So let's say we want to find the probability of getting tails all 3 times when we are doing 3 coin tosses. Probability of tails for the first one is 1/2, and also for the second one, and also for the third one. So we would just do 1/2 times 1/2 times 1/2, which works out to be 1/8. The last concept that we'll look at in this video is what we refer to as odds. Odds are basically just probabilities re-expressed as a ratio instead of expressing it as a fraction or decimal or percentage. So if we want to convert odds to probability, we can use this little formula right here, where E is our event, F is our favorable odds, and then U is our unfavorable odds. So if we're given that the odds for an event are 3-to-1 in favor of event E, then our probability of E, that means if this is our favorable and this is our unfavorable, then our probability is just going to be 3/3 plus 1, or 3/4. If we wanted to go the opposite way and convert probability to odds, then we would just say, take our probability. So if we wanted to use the same example, 3/4, if we want to re-express this as odds, A in this case would be 3, and then B is going to be 4, so our odds would be A to B minus A in favor of this event. So that would be 3 to 4 minus 3, or in other words, 3-to-1. So essentially odds Again, they're just a way of re-expressing our probabilities, but instead of saying that the probability is 1/8, for instance, 1 in 8, you could say something like the odds against this are 7-1, or the odds in favor of this are 1-7. Basically, you are expressing your probability as a ratio of favorable to unfavorable outcomes, rather than expressing it as a fraction or a decimal or percentage. Thank you for watching, and as always, I'm happy to help with questions.